Hello everyone, welcome to lesson number 9 for Calculus AB. In lesson 9, we're going to talk about derivative graphs and differentiability. There are 3 different types of questions that we're going to do in lesson 9. The first one we're going to talk about is looking at a function and looking at its derivative, compare their graphs, and see what similarities we can get from comparing both those graphs to each other. In the second part, we're going to look at differentiability, and we're going to talk about where functions are not differentiable. And in our final video, we're going to look at how to prove differentiability based on our algebra, based on the algebra skills that we learned in calculus. So let's go ahead and start with example number 1. We're going to start with a very, very basic example where we have the function y equals 3x. As you guys can see right here, we're looking at y equals 3x, and this is the graph for y equals 3x. Well, the derivative of y equals 3x is going to be equal to 3, and so this is going to be the line y equals 3. So everywhere that you see an x value, the y value is going to be 3, so it looks like this. And so I want you guys to notice a couple things about this, is that the slope for this graph, right, the slope for this graph is always positive. Okay, and that's pretty straightforward. And why am I telling you that? Because, again, this is a very basic example, but notice that for this graph right here, our slope is kind of equivalent to our derivative, again, this is the rate of change. So when it's positive, our y values, our slope is going to always be greater than 0. So whenever you see that a slope is positive, you should be expecting to see the function above the x-axis. If the slope is negative, and we're going to talk about that in the next example, if the slope is negative, then your function is going to be below the x-axis. So that's our very first comparison that we're going to do in our comparison of derivatives. The other thing I want you guys to understand is that this degree is 1. Right, the degree of this function is 1, and the degree of this function is 0. So as you're taking a derivative, the degree goes down by 1, right, by the power rule. So if I ask you guys to take the derivative of 3x cubed, well, that derivative, and this is a cubic function, that derivative is going to be 9x squared. Now we're at a quadratic. We take the second derivative of this, we go from a degree of 2 to a degree of 1, and then we take our final derivative, we're going to get down to a degree of 0. So as we're taking the derivative, our degree is going down by 1. Okay, so let's look at the second example and talk about this. Oh, and one more thing I want to say about this example right here is that this slope is very constant, right? As I go here to here, that slope is 3. Here to here, that slope is 3. Here to here, that slope is 3. And so that's exactly what you see right here. So no matter where we put a point on this graph, our slope of that value is going to be 3. The tangent line to that's going to be the actual line itself, right? And so that's going to always be equal to the slope of this line, which is going to be 3. So just throwing that out there to you guys as we look at number 2. So for example number 2, we're looking at the function x squared, and you guys can see right here, we have our function x squared, and we're going to take the derivative of x squared using the power rule, and we're going to get that this derivative is 2x, right? This derivative is 2x. So we're going to go ahead and we're going to draw ourselves a little line where our slope for the entire graph is going to be 2x. And then we got a couple of interesting things to talk about with these graphs. So let me go ahead and draw my little line here. So here's the line y equals 2x. And so again, you guys realize that we have a quadratic, which is a degree of 2, to a straight line that's a degree of 1. So that's a very good representation that this right here has a degree of 2, and this right here has a degree of 1. All right, so that's the first thing, the obvious thing that you guys can look at. All right, so here's what else we need to look at. So on the interval from negative infinity over here to 0. So well, let's just be simple. Let's go negative 3. So just say from negative 3 to 0. Notice that the slope of my line, right, the slope of my line is negative. So in this particular region right here, my slope is actually going to be negative, right? Or if I ask you to draw a tangent line on this graph, it's going to have a negative slope. So no matter where I talk about my tangent line, it's going to be a negative slope. Let me actually change the color up on this so you guys can see a little bit better. So the slope of a tangent line is going to be negative. Well, notice that from negative 3 to 0, right? So that's going to be this region right here. Notice that from negative 3, and let's just do this part right here. Notice that for this, our derivative, right, our derivative is actually going to be less than 0. And that should make a lot of sense because this is the value of the slope. This is the values of the slope. So if I ask you guys to find the derivative or the tangent line on these points right here, they're going to be negative. They're going to be negative. So the value of your derivative graph will be negative here. If we can go to the right side of this and say now from 0 up to 3, again, anywhere I draw a tangent line, my slope is going to be positive. So the slope of this is going to be positive. Since these are equal to each other, slope and derivatives are basically the same thing, my value of my slope needs to be positive. So this is why your graph is above the x-axis. Okay, that's why we're looking at the graphs like this. If I look again at this bottom part, at x equals 0, the tangent line to this graph is 0, right? The slope of the tangent line is at 0. And this value right here is actually at 0. So whenever we cross the x-axis, that's going to tell us that we have a max or a min, right, for our derivative graphs. So hopefully that makes sense. Let's go ahead and look at 4 more examples of this and start comparing basic stuff with just slope. So let's look at the next example. Okay, so for these examples here, we have function graphs and we have derivative graphs. And we want to be able to sketch or get an idea of matching which of these derivatives match these f of x graphs. So the first thing that I notice with example number 1 is this. I notice that the entire graph from left to right is always positive. So the slope for this graph is always, always, always positive, which means that my derivative graph is going to always be above the x-axis, because above the x-axis is going to be positive. So we have 3 graphs, these 3 graphs right here, where the graph is above the x-axis. What I also noticed about this is that if you look at this part right here, all right, so this graph right here is concave down. Okay, this is going to be concave down, which means that the slope of my function should be negative. So this is going to be concave down, which is our second derivative, which means that the first derivative slope has to be negative. And so this is where I'm starting to eye this problem. So this is where we're looking at this part. I can go back and say the same thing with this, that this is going to be concave up. This is going to be concave up. And so I know that my derivative graph will be positive here. Because remember, if my first derivative is positive, then that means, the slope of my first derivative is positive, then my graph is going to be concave up. Another thing that, again, ladies and gentlemen, that we're going to say about this graph is that, again, it's all going up, right? My slope is always increasing, always increasing, always increasing. Therefore, it's going to be above the x-axis, okay? And then the last thing we can say here, and I've kind of lost a little of my integrity of my problem here, so let me erase this. The thing I want to note right here about this problem is that if you look at x equals 1, right, x equals 1, my function has a horizontal tangent at x equals 1, which means that the slope of this tangent is what should be matching over here. The value of this line should be over here, and that's why it's crossing at x equals 1. Okay, so we know that the answer to question number 1 is going to be D. So that's example number 1. Let's look at example number 2 and see what we can do with this graph. Now, we've actually done one just like this. I think it was the exact same problem that we did before, but let's actually talk about it again. So since I'm negative, right, since my slope to the left of 0, all right, so to the left of 0, my slope is negative to the bottom of 0. So if I look here at 0, then the bottom of that has to be underneath. It has to be underneath the x-axis, because again, of the sine. Again, we have a quadratic here, by the way. You guys can see this is an x squared, and this is a line. So that's the natural, easy way of identifying that. But we like to go a little step further with this, and that also, again, this is positive, so therefore, this is going to be above the x-axis. So when our slope of f of x is negative, or if we try to create a tangent line and it's negative, it's going to be below the x-axis. So that's the thing that we want to write about this, is that if my slope, so if my derivative is less than 0, which means that my slope is negative, then you guys can see this. If it's less than 0, it's going to be underneath 0, right? This value is going to be less than 0. And then again, if my slope is positive, that means that slope of f of x is going to be positive, right? Because that's exactly what this is. So it's going to be above the x-axis. The other thing that I can say about this is that this is always concave up, right? Everywhere the entire graph is concave up. And since it's all the way concave up, I'm going to always be increasing. I'm going to always be increasing on my graph. So that's another way of thinking about things with our graphs. So let's actually write that down in our little notes as well. So when our f of x is concave up, then your slope, your second derivative, is going to be positive, right? Which is going to be the slope of f of x. F prime of x. Okay? So that's what we can look at for this. So these are a lot of things. And we're going to do a nice little summary of all of this stuff at the end of this lesson. All right? At the end of this lesson. So let's see what else we can do with these problems. So let's look at example number 3 and talk about this one. So notice that again, ladies and gentlemen, for number 3, it's always increasing. So we always want to look at slope first. So if there's nothing else that you're getting out of this, first of all, notice that the slope here is positive. The slope here is positive. Slope is positive. Slope is positive. Positive. So that means that f of x is always increasing, right? It's always increasing here, here, and here. So that means it's going to be above the x-axis. It's going to be above the x-axis. Well, both of these are above the x-axis, so we got to go a little bit further with this. Well, another thing we can look at here is that this is going to be concave up, right? This is up. And this is going to be concave up right here. And this is going to be concave down. And this is going to be concave down. So what this means is that when we're up, the slope of our derivative graph is going to be positive. And so if you guys look over here at this one, the slope is positive here, which is again between these values. And the slope is also positive here. And that's what's matching what you see right here. So from, let's say, -3 to 2, -3 to 2, right, it's positive. And then again, from 0 to 1, it's positive. Well, now these are negative, right? These are concave down. This function is concave down, which means the slope of my derivative, should be negative. And that's what you see here and here. So then we know that this answer is going to be B. And this answer right here was actually going to be A, right? We've already talked about that. So let's see if we can figure out this last example here. And again, there's a lot of stuff going on my thing. So I'm going to let's get rid of all of it for a second. So let's get rid of all of this stuff, just so we can get a little clear with what's going on. So again, ladies and gentlemen, I'm always positive, right? I'm always positive. So this is always increasing. So if I put a tangent line here, I'll put a tangent line here, it's positive. So again, I know that my function, my derivative, is always going to be above the x-axis because these are the actual values. This represents the values of the slope of the tangent line at these values of points. One thing you guys can see about this graph is the fact that it's starting to level off, right? It's going to get closer and closer and closer to the value of 0. And that's why this graph is actually getting closer and closer and closer to 0. So that's another way to think about it. It's also concave down, right? This whole graph right here is going to be concave down. I'm looking at a sad concave down. And that's why this graph is always decreasing. Okay, this is why this graph is always decreasing. So taking all of that into account, we can figure out what we need to know. So let me actually do a little summary of what we just did on the next page. Okay, so here's what I want to do first. So I want to talk about what's actually happening, because normally they're going to give you the derivative graph and you got to figure out what the f of x graph is. That's usually how it works in calculus. So I want you guys to understand something really fast, is that if my f of x graph is positive, okay, which means, again, if it's positive, it's above the x-axis. We would never justify it by that, but we would say it's above the x-axis. Okay. So if this thing is positive, that means that f of x is going to be increasing. Okay, it's going to be increasing, which means that my function is literally going to be going up like this or up like this. Okay. This is concave up, this is concave down, but my function is still going to be increasing. If my derivative graph is below 0, then I'm going to be below the x-axis. Again, we never ever justify stuff by what's in the parentheses. And that just means that f of x will be decreasing. It's going to be decreasing. And it'll be decreasing concave up or decreasing concave down. Okay? So that's the first little part of what we just have to understand with these graphs. So if I'm asking you guys to look where it's increasing, where f of x is literally going up, then that value, that range should be, your derivative graph should be above the axis on that interval. Okay, so if we give you guys the derivative graph, f prime of x, and you see this very basic graph right here. So on the interval from 0 to 1, notice that f prime of x is positive, right? The value of f prime of x is positive because it's above the x-axis. So over here from 0 to 1, I don't know exactly where we would do this, but right now we just know that that function is going to be increasing, right? Because it's above the x-axis. And then from 1 to 3, my value is going to be negative. So I know from 1 to 3, I'm going to be decreasing. And then from 3 to 4, my function is now above the x-axis again, so I'm going to start increasing again. And so that's the idea of what's happening with this graph. Okay, so that's kind of what we're going to do, and we understand that way. So we're going to come back into the next video and talk about other parts of differentiability. But hopefully this was somewhat helpful with what you guys are doing. But right now, all we're going to care about is the fact that when this is increasing, when f of x is increasing, then your slope is going to be above the x-axis. The derivative of your graph is going to be above the x-axis. When f of x is decreasing, then the slope of your function will be below the x-axis. We got a lot more stuff we're going to talk about with these derivative graphs later in this course. But right now, this is really what you need to know. So increasing, my derivative is positive. Therefore, the graph will be above the x-axis. F of x is decreasing. It's going to be negative. Therefore, my slope is going to be below the x-axis. Okay, so let's come back in the next video and talk about some more differentiability.